Welcome, Calculus AB. This is lesson 3.1, position, velocity, and acceleration. Let's begin. So, a few definitions before we start this. What is position? What is velocity, acceleration? You might have heard about this in a physics class, but just to review. Position's like where you're at. So it's like a distance right here. How far are you away from where you started? Velocity, and it can be negative or positive. In each of these cases, these can all be negative or positive. Velocity is how fast you're going in your direction. So you might have positive velocity or you might have negative velocity. Just depends, positive or negative. Acceleration is how fast you're speeding up or slowing down, and it can be positive or negative. I like to think of this like a car example. So position's like how far you've gone, and velocity is like your speed, sort of, but like your speedometer, but kind of. It can be negative though, like you can go backwards. And acceleration is like hitting your gas pedal or hitting your brakes. Brakes would be negative acceleration. You want to change how fast you're going. So a little bit about like what units we're talking: position, velocity, acceleration. So there's always a distance unit and a time unit. So distance could be meters, miles, centimeters, inches, feet, whatever kind of distance. In times, talk about seconds, minutes, hours, days, any kind of measurement of time. So a position, the units for that is going to be just a distance unit, meters or miles. Velocity is going to, so it might be represented just m, if it's meters. And velocity might be like meters per second. So sometimes we represent it as meters per second, just like this, or m divided by s, however you want to write that. Acceleration is meters over seconds squared. This might look like meters per second squared, something like that. So it's going to be important to have unit notation when you're doing these kind of problems. Other definitions to talk about here, and we'll go over more in class. We have a position function. So sometimes a position function like gives your location of the object, and we might label these s of t, x of t, or y of t. X of t if we're talking like a particle moving on x-axis. Y of t is like we're talking particle moving on a y, or the height of something is maybe like a y. And sometimes we s of t, I've seen d of t, but whatever your position function. Velocity functions, your rate of change of your position. So how fast your position is changing, kind of like, but not really speed. It's like how fast it's moving. So you usually label that as v of t. So it can be both positive and negative. Accelerations, how fast the velocity is changing, we label that as a of t. Now, so we have this concept of initial position and velocity. So sometimes we label those as s sub 0 or v sub 0. I've also seen notations like s of 0, like this. You might see that notation a lot in this class, or v of 0. And yeah, those are or sometimes you see s sub I for initial, or v sub I. Your physics classes might use different notation, but I think we'll tend to use this kind of function notation in this class, but expect to see that sometimes as well. Your speed is an absolute value of velocity. So velocity can be negative, speed can't be negative. You're going backwards 10 miles an hour, your speed is 10 miles per hour, but your velocity is negative 10 miles per hour. Now displacement is your net change. So it's like where you started and where you end. So if like you start at home and you do a walk around your neighborhood and come back, at the end of that your displacement's 0 because you just didn't move at all. But you didn't change your position by the end. But you did walk around, and to account for that, we sometimes call that the total distance. So it's the total distance you traveled. Because like sometimes you might travel in the positive direction and negative direction, and you get back to the same spot, but we have to, total distance would be accounting for all that movement. Displacement doesn't account for that movement. It just looks at where you're at the start and where you're at the end. Doesn't care what kind of loops you did to travel there. All right, using calculus and those things. So there's a relationship between position, velocity, and acceleration, and it's through derivatives. So if you derive the position function, you're going to get the velocity function. So if my position is s of t, s prime of t is equal to the velocity function v of t. And if you derive the velocity function, you can get the acceleration function. So v prime of t is a of t. Another way of saying that is s, the second derivative of position, goes to acceleration. So if you just derive it twice. So let's do an example here. If I say my position function is 3x squared plus 6x minus 5, my velocity would be the derivative of this, so 6x plus 6, and acceleration would be derivative velocity, which would be 6. All right, so this is a key part to this lesson. Understanding position, velocity, acceleration are derivatives to find those. So let's take an example here. I have this position function of an object moving on a horizontal line, so like up and down. So distance are measured in feet and time units are measured in second. So you might have to answer a lot of different types of questions. What's the initial position of the object? So when I say initial position, I mean your position at time equals 0. So S sub 0, if you're plugging in 0 for t, that's going to come out to 24, and it's going to be feet. Position is a measure of units, feet. Velocity of an object at time equals 0 is at time equals 1, so that means I want to find v of 1. Well, I have to find v of t first, and I know that's the derivative of this function. So v of t, which is your derivative of here, is going to be 3 times 16, which is going to be 48t squared, minus 72t when you derive this, and then plus 0. So v of 1 is going to be 48 times 1 minus 72 times 1, and that'll give you negative 24 feet per second. I'm going to put my units there. What's the speed of the object as 1? Well, if my velocity is negative 24, speed is the absolute value of velocity. The absolute value of velocity. So it's going to be the absolute value of v of 1, which is just going to be absolute value of negative 24, which is positive 24 feet per second. And what's the acceleration of the object? Well, that's finding a of 1. So I have to find the derivative of velocity here. So my a of t is my v prime of t. So derivative of this will be 96t minus 72. So a of 1 is going to be 96 minus 72. And if you do that math, that's going to give you 24 feet per second squared. Remember, it's seconds squared. All right, save some more examples for class. Here's another picture. So this graph shows a position function. So sometimes we have to understand that derivative of velocity or derivative of position is velocity, which is basically the slope of the tangent line. So this is a graph of position of some radio-controlled model car. So it's like starts at 0, and then it starts moving, and it gets up here at the top, and then it comes back down to where it started. So think of this as like the height or how far the car has traveled out. It's traveling out pretty far, but what it's doing is then it comes back at the end. So is the car going faster at A or B? Actually, think about these, but we'll probably save these for class because I think those will be easier to explain. So I want you to think about these, but we'll talk about it in class. All right. We'll also save this for class. I'm going to be done. Bye.